Hello everyone, myself Piyush Tandil, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Power System Planning and Design, which comes in 4th year, 8th semester. Right now we are discussing the design of power system, that is the chapter number 3, and this is the module number 3.2. So in this module, we are going to see the concept of interconnection and then after types of interconnection power system. So let's begin with the concept of interconnection. Concept of interconnection. The main requirement of any power system is to give uninterrupted continuous power supply. That's why we are consuming the power, right? Because we require uninterrupted power supply from the supplier side. So in some part of the country, there are resources of generating power, but their requirement is low, whereas in other parts the power requirement is large as compared to the available resources of power, right? So somewhere there are large amount of power generation, but the requirement, or we can say the load that required to consume that power is very much of low, and in other part there are large amount of demand, but the generation of the power is not going to meet that large demand. So this difficulty can be reduced by interconnection different power station. This difficulty can be reduced by the interconnection of different power station in the parallel form. Okay, now the continuous connection of number of power generating station in parallel is known as interconnected power system. So this is the point you need to remember, that is the connection of number of power generating station in parallel is known as an interconnection power system. Now interconnected power system is basically an interconnection of buses of more than one generating station so as to utilize the unused generated power capacity of connected generator during the peak demand. Okay, so this is the advantage of interconnected power system. Now it is also be simply defined as a distribution system with multiple available power source that can loop throughout the network. If one source goes down, a different source can activate to maintain the main service. Okay, so this is the also advantage of interconnected power system. We can also distribute, or we can say the uninterrupted power supply can be fed by the supplier side. Now here we can see the figure, that is the representation of interconnected power system. Over here we have generator 1, over here we have generator 2, and this is our load. So load is connected via generator 1 and generator 2, and this both the generator are connected via this transmission line, and this is the line 1, this is the line 2 that is going to feed the load, and current from the generator 1 is I1 and current from the generator 2 is the I2, and over here we have our bus, and here we have different amount of loads, different types of different amounts of load that are going to be fed with the help of generator G1 and G2. Now this figure shows the interconnected power system having two power generating station, that is G1 and G2, and the current, that is I1 and I2, throughout the transmission line, that is line 1 and line 2. The power generating station are also interconnected by this transmission line, which is carrying current I1, and the transfer of power is taking place as shown in figure direction. Now the other, both the transmission line, that is transmission line L1 or transmission line L2, deliver equal power to the system, operates at the same terminal voltage. It is necessary to active component of the line current I1 equals to I2. Now we are going to see the types of interconnection power system. So there are basically mainly three types of interconnected power system. First one, that is the AC interconnection. Second one, that is the DC interconnection, and last one, that is the hybrid, or we can say AC-DC interconnection system. So let's first see the AC interconnection system. So this is how AC interconnection system is going to be look like. So figure shows the AC interconnection scheme, and two system is directly connected. Okay, two system is directly connected to each other with converting station. So whatever we are going to convert, we are going to convert the voltage level, or we are going to convert the current level. Now next we are going to see the DC interconnection system. Over here we have system A, and over here we have system B, right? So in DC interconnection system, both the system A and B having no converting station. to change the voltage level and control the voltage. The transmission line, the transmission of the power block over long distance is however utilized by the HVDC. So we are going to use HVDC, high voltage DC transmission line, in the interconnected power system. Okay, now next one, that is the last one that we are going to see, is the hybrid, or we can say AC or DC interconnection system, in which we are also going to use AC as well as DC. Oh yeah, this is DC line. Okay, so figure shows the hybrid interconnection system. Both AC and DC power are transmitted over long distance of time. The hybrid interconnection system could therefore offer the best possibility for large system interconnection in the case of continuational network and consisting of number of small systems. This is all about the different types, that are the AC interconnection system, DC interconnection system, and hybrid interconnection system. Now next one that we are going to see is the problem that are associated with the interconnected power system. So there are many problems that are associated with the interconnected power system. The first one, that is the voltage control. Now it is necessary that the constant voltage is maintained in the interconnected power system. So the problem of low voltage is mainly serving in summer season due to the heavy inductive load of air condition, fan, water pumps, and etc. Right? So this problem can overcome by meeting the reactive power requirement at the load center. It can be overcome by connecting the capacitor in front of the line to provide the reactive power to the system. So that is how we can control our voltage. Now second one, that is the frequency control. So it is known that for the proper system operation, the system frequency should be maintained at least between 48.5 hertz to 50.5 hertz, that is 50.5 hertz. Okay, this is where we need to maintain our frequency level. So in some cases during peak load condition, frequency tend to be very low, that is about 48.5, and in average loading condition, or where we can say the peak load is off at that time, the frequency can goes up to 50.5. Now under this condition we can use the frequency relay for automatic load schedule, automatic load setting, for from which we can setting our load and connection of new generating unit in the parallel. So that's how we can rectify this frequency control. Now next one, that is the load dispatch and communication. So the present load dispatch and communication facility are inadequate. The present power line carrier communication, that is PLCC, power line carrier communication system, cannot be expanded due to the congestion in available frequency spectrum, difficulty in cascade random operations, etc. So it is proposed to add multiple channel digit microwave system and fiber optic communication system to provide better load dispatch and communication facilities. So that for that we require better fiber optic communication systems. Next one, that is the shortage of spinning rivers. Now during the peak load time, the demand is more than the power generation. For the better load management, the additional generator facility is needed to be added. Okay. Now next one, that is the lack of operation discipline among constituents. In interconnected power system, each constitute in a region maintain a balance between its own generator and demand. However, due to overall shortage in installed capacity, the constituents tends to overdraw share from the central stations. Due to this distribution creates in system, the system stability problem is going to be occurred. Now next one, that is metering and instrumentation. So adequate metering and instrumentation is needed at a different levels. It is necessary to install sequential recorders, disturbance recorders, or we can say disturbance recorders, and time day metering instruments, etc. to monitor our power flow and regulate our power flow. Okay, this is all about the problem associated with the interconnected power systems. Next one, that is the advantage of interconnected power system. So in interconnected power system have following advantages. The first one, that is the exchange of peak load. Now an interconnected advantage of the important advantage of interconnected power system is that peak load of the power station can be exchanged. If the load curve of the power station show a peak demand that is generated than the rated capacity of the plant, then the excess load can be shared by the other stations which are interconnected with the power system, right? So with the help of this kind of configuration we can exchange our peak load. Now second one, that is the use of older plants. Now how we are going to use our older plants? That is the main interconnected power system make it possible to use older or less efficient plant to carry peak load only for the short duration of time, right? Because we are not connecting our older plants or the less efficient plant 24/7. We are only requiring those plant in the only peak hours, or we can say for the short duration of time. So although such plant may be inadequate when used alone, yet we have to sufficient capacity to carry the short peak of the load when interconnected with the power systems. Now next one, that is therefore interconnected power system gives the direct key to use the older plants, or we can say the inefficient plants. Now ensure economical operations. Now the interconnected system make the operation of concerned power station quite economical. Now it is because sharing of load among the station is arranged in such a way that more efficient station work continuously throughout the year at a high load factor, and less efficient plant work for peak hours only. So that's how we can obtain our economical operations of the power system. Next one, that is the increased diversity factor. Now the load curve of different interconnected stations are generally different, and the result is that the maximum demand on the system is much reduced as compared to the sum of individual maximum demand on the different stations. In other words, the diversity factor of the system is going to be improved, and thereby increasing the effective capacity of the system. Next one, that is reduce plant reserve capacity. That is the every power station is required to have a standby unit for the emergencies, right? However, when several power stations are connected in parallel, the reserved capacity of the system is much reduced, and this increased the efficiency of the power system. Next one, that is the increase reliability of the supply. That is the interconnected system increase the reliability of supply. If a major breakdown occurs in one station, the continuity of the power system can be maintained, or we can say our system can be stable in the handling condition by the interconnection of different generating station, right? So this is the different types of, or these are the different types of advantages of the interconnected power systems. Now we are going to see the disadvantages of the interconnected power system, right? So disadvantages of interconnected power system are synchronizing problem. So the generator of all the interconnected power system must generate the same frequency and in synchronized manner. During the heavy load condition, some generator goes out of step due to the synchronization breakup. And finally, complete system goes out of the step and called as a blackout condition. So this is the major problem that are normally occurred inside of the interconnected power system. Now second one, that is the expensive tie line, because we are interconnecting different generator, right? So in interconnection power systems, to control the system reactive power, tie lines are used, and expenses of the tie line for construction of interconnection transmission line between generating station is very high. Next one, that is the expensive circuit breakers. An interconnection system use circuit breaker to isolate the faulty part from the healthy part during the faulty conditions. For high voltage power system, high rating circuit breaker is used during the large flow of current on a transmission line under the faulty condition, with consequent increase in the capacity of the circuit breaker. Therefore, expensive circuit breaker are required with interconnected power system. Hence, the cost of circuit breaker is also going to be increase. And last one, that is the metering and instrumentation. Adequate metering and instrumentation is needed at a different level. It is necessary to install sequential recorders, distribution recorders, and time to time metering devices, load flow calculations, and all the metering instruments that are going to cost us more in interconnected power systems. So these are the disadvantages of interconnected power system. And today's last topic, that is the reserve capacity of interconnected power system. So every power station has certain amount of reserved capacity to facilitate periodic maintenance and repair of generating unit and to meet the demand of power when a unit has a forced outage due to the fault. Okay, the reserved generator capacity may be classified into two categories, that is first one, that is the cold reserve, and second one, that is the operating reserve. So what is the cold reserve? The cold reserve is the reserved generator capacity which is available which is available for several services but not in operation. So this is in service but not in operations. This is in service but not in operations. And it is used when the generating unit is to be taken out of maintenance or repairing conditions. Now next one, that is the operating reserve. So the operating reserve is the reserve capacity which is required to provide for minute to minute variation in load forecasting error and forced out of unit. It is also two type, that is operating reserve capacity is also two type, that is first one, that is the hot reserve and spinning reserve. Now hot reserve is, it is that operating reserve capacity which is in operation but not in service. So this is not in service but it is in operation. And spinning reserve, that is, it is the operating reserve generating capacity which is connected to the system bus and ready to take load. So that is the spinning reserve capacity, and it is provided to meet the minute to minute load variation and any extra load due to the load forecasting errors. So this is the cold reserve capacity, operating reserve capacity. Inside of the operating reserve capacity we have hot reserve and spinning reserves. Okay, this is the reserved capacity of interconnected power system. And here are some of the questions that are already asked in G2 examination, like the first one of what is interconnection, state advantage and disadvantage of the interconnection, which may be asked in 4 marks. So you have to write the definition of interconnection and then after advantages and disadvantages and explain these advantages and disadvantages in details. And second one, that is the what are the type of interconnected power system. Inside of this we have to define all the three types that happen: AC interconnection system, DC interconnection system, and hybrid, that is AC and DC interconnected system. The question may be asked in 3 marks. Next one, that is the what are the problem associated with the interconnection system, in which we have to mention all the different problems that we have seen in this video lecture. And last one, that is the explain reserve capacity of interconnected power system, inside of which we have two different capacity that are cold reserve and operating reserve, and inside of the operating reserve we have also two different type, that is hot reserve and spinning reserve. So you have to explain all these for the 3 marks. That's it for today's video. Thank you, and if you have any kind of query regarding this video lecture, then please feel free to ask me. Thank you.